The Cognitech Tri-Suite software package includes Cognitech Video Investigator, Cognitech VideoActive, and Cognitech AutoMeasure. Video Investigator is Cognitech's comprehensive video processing platform for extracting the utmost available clarity from image or video sources. One of Video Investigator's primary functions, FrameFusion, will be covered in this interactive tutorial. Welcome to the Cognitech Video Investigator FrameFusion tutorial. This interactive tutorial will focus on calculating motion information and producing a super resolution FrameFusion reconstruction. The first step is to open a file. Files can be opened with the Open File icon in the icon toolbar. Click Open File to continue. The evidence video has been selected. Click Open to open the video evidence. This video has been deinterlaced and is 1/2 of its true height. In order to view this video in its original scale, it must be zoomed vertically. The zoom tool can be found in the toolbox. The zoom tool zooms the preview image and will not affect the processed video. Click the Zoom tool. Clicking the Zoom tool expands the options available in the toolbox. Select the Zoom Vertical tool. Zoom the evidence video by clicking the video. Now the video is visible at the proper scale, but it is still difficult to see what content is present in the video. Limiting the histogram bounds will provide more definition to the video. This can be done with the histogram editor. Limiting the histogram bounds reveals new details. Histogram bounds adjustment was applied to all frames and provided more definition, but is a detailed face identification possible. Adjusting the histogram bounds of the video provides better contrast. Toggle the checkbox to see the histogram bounds adjustment. As you can see, facial details are still obfuscated by noise and a lack of resolution. Velocity plugin modules perform apparent velocity estimation by performing computational matching registration between video frames. The result is a velocity vector that is attached to each pixel. Velocity vectors are utilized in motion deblur, stabilization reconstruction, FrameFusion reconstruction, and mosaic reconstruction. Cognitech Video Investigator has 3 available velocity filters: correlation matching, manual matching, and shape matching. The motion models section determines what combination of motion models will be used for calculating velocity vectors. Deselecting unnecessary motion models will increase the accuracy of the velocity calculation. Here are the illustrations of the motion models available in the shape matching velocity filter. The motion range section determines what range of motion will be used to calculate velocity information. Limiting motion range will more accurately determine the velocity of the desired shape. However, a desired shape motion outside of the motion range will not be tracked. Velocity for FrameFusion reverses velocity vectors and is used when calculating velocity for FrameFusion. Full rotation allows for large rotational changes. This option should not be used unless a large rotational change occurs. Artificial intelligence utilizes adaptive thresholds to match shapes. This option is enabled by default and typically provides better results. The Track Match window automatically tracks any object selected in the video. This option is currently in development and will be available soon. Target frames determines which frames get matched when determining velocity information. Target frames are numbered relative to the current frame position. This simple velocity pattern simply compares the current frame to the next frame and is the default velocity pattern. This example of an advanced velocity pattern compares the current frame to each of the next 3 frames and stores a separate velocity pattern for each. All parameters and object selections can be copied between frames using the active interface. When activated, the active interface will provide an instant preview of the filter applied to the evidence. Before we can utilize FrameFusion reconstruction, velocity information must be computed. Open the Filters menu to continue. Velocity filters are found in the Velocity category. Open the Velocity submenu to find the proper velocity filter. Several velocity filters are available in Video Investigator. Click Shape Matching to open the Shape Matching velocity filter. The motion in the evidence video contains only translation. Deselecting unnecessary motion models will increase the accuracy of the velocity calculation. Remove the rotation, zoom, general zoom, affine, and perspective motion models. The Velocity for FrameFusion option reverses velocity calculation vectors, which is ideal for FrameFusion. Select the Velocity for FrameFusion option. Target frames determine how many frames forward and backwards are to be compared when determining velocity information. Select target frame -3. Select target frame -2. Select target frame -1. Select target frame 2. Select target frame 3. Selecting the object of interest in the evidence video can produce more accurate velocity calculation and in turn better FrameFusion results. Click the Selection tool to make an object selection. Now that we have applied an object selection on a single frame, we need to duplicate the selection and filter parameters to the other frames in the video. Once the object selection and parameters have been duplicated, each frame can be easily customized independently. Toggle the active interface copy type to parameters and selections. Click Copy to copy the parameters and object selection from this frame. Click Duplicate to copy the parameters and object selection to all other frames. To save time, we have gone through each frame and adjusted the position of the object selection to follow the position of the face. Click Process to calculate the velocity in the evidence video. Cognitech filters with active interface process each frame according to its individually defined parameters and object selection. Click Finish to choose the shape matching velocity filter. FrameFusion integrates information from adjacent frames into a current superframe for enhanced resolution and noise reduction. Adjacent frames are matched using the calculated velocity vectors. FrameFusion utilizes velocity filter motion vectors to match multiple frames into a single, larger superframe. Accurate velocity information is crucial to properly fusing neighboring frames into an accurate superframe. FrameFusion is found in the Reconstruction Filters category. Reconstruction filters provide increased resolution and differ from traditional enhancement filters, which are limited to their original frame resolution. The Input Types section allows a single movie or multiple movies' images as the source material. Currently, only the single movie option is available. The multiple movies images option is currently under development. The Interpolation Methods section allows the user to adjust how unknown pixel values are determined. The spline method is traditionally suggested as the fastest and most accurate option available. The Zoom section specifies scaling factors to enlarge or shrink the output image with respect to the original image size. The values are linked by default and can be specified independently by toggling the link button. Generally, specifying a zooming factor during fusion will provide a better result than applying a zooming factor after. The Fusing Frames section specifies the pattern of the reconstruction with some or all of the frames in the neighborhood of the current frame. Increasing the number of fusing frames will provide further information. However, velocity calculation error may increase with the number of fusing frames, causing blur. The Velocity Patterns section shows available velocity patterns for the current frame. Patterns are derived from previously calculated velocity information. Now that we have velocity information properly calculated, open FrameFusion, found in the Filters menu. FrameFusion is found in the Reconstruction category. Open the FrameFusion filter. FrameFusion shows its results in the Superframe window. The Zoom tool we used previously does not get applied to the superframe. The best way to resize the image is to adjust the zoom parameters in the FrameFusion filter. Unlink the zoom parameters so that the vertical zoom can be increased without affecting the horizontal zoom. Change the value of Y to 2 in order to double the height of the evidence in the video. Now that we have set the proper zoom factor output of the FrameFusion filter, we will now adjust the preview zoom so that we can more clearly see the effect of FrameFusion on the video. Open the Zoom tool. Select the Zoom In tool. Click the source video. Click the superframe video. Zoom the source video again, and zoom the superframe video again. Fusing frames establishes how many frames will be fused to the current frame. Increasing the number of fusing frames provides more pixel information for the FrameFusion. However, if the velocity information is not perfect, too many fusing frames can cause blur. Enter 10 into the Before Fusing Frames field. The 10 fusing frames make no difference to the superframe because we are on frame 1 and there are no previous frames to fuse. Enter 1 into the After Fusing Frames field. Fusing one frame to the superframe improves the video, but increasing the number of fused frames will provide better results. Enter 2 into the After Fusing Frames field. Enter 5 into the After Fusing Frames field. Enter 10 into the After Fusing Frames field. Enter 15 into the After Fusing Frames field. The effect of fusing 15 frames after frame 1 can be seen in the superframe. Copy the parameters we have applied to the first frame using Copy. Duplicate the parameter settings to all other frames in the video using duplicate. The same parameters have been applied to all frames in the video. Click frame 5 to see what frame 5 looks like. Click frame 10. Click frame 15. Click frame 20. The same parameters have now been applied to all frames in the video. Click Process to apply FrameFusion to the video. FrameFusion integrates information from adjacent frame pixels into superframes, enhancing the resolution. Click Finish to close the FrameFusion filter. FrameFusion provides enhanced resolution and noise reduction. Toggle the checkbox to compare before and after FrameFusion reconstruction. Here is a comparison between the original video and FrameFusion video after histogram adjustment. FrameFusion not only reduces noise, but actually increases image resolution. Here we have zoomed in to see the increased FrameFusion resolution. Notice in the FrameFusion video that the driver can clearly be seen using a cell phone while driving. This information is not clearly discernible in the original video. With FrameFusion, enhanced facial features of this individual make identification possible. Click Continue to end this tutorial. You have now successfully enhanced a video with FrameFusion. With practice, the video can even be reconstructed beyond the limited resolution of the capture device. Try FrameFusion and see how super resolution can work for you. If you would like to return to the beginning, click Restart Course. For sales or technical questions, contact us at sales@cognitech.com or tech support@cognitech.com, or visit us at www.cognitech.com.